Right, okay, sorry about that. Yeah, I'm back. Yeah, the flipping stream just dies every now and then. I just don't know what's going on. I wonder if I'm low on disk space or something. Let me just check my disk space. Is that working again now? Well, I've got 4.8 gigabytes on the drive that I'm storing all this stuff on, so it should be alright with space. It's probably bandwidth problems. Right, okay, so I've chucked that wire link out and I've put a resistor in, and it's too high value, so I need a low value resistor. Right, I'm alive. Okay, I'm going to look at putting something a bit lower in, because that 1K is a bit too high. So something like a 500 ohm or something like that. Find something in this box of tricks. Oh, there's got to be something that's 30 ohms. That's a bit low, too low. I want something about 100 ohms or something like that. Oh, I can't see these colour codes. It's just really bad. Oh, what's this one? Oh, these probes are really bad. That looks like 80 ohms or something. It's 82. Actually, no, that'll work. 82 ohms. That'll work. I'll try that one. Right, so is this off? Right, it is now. Now I'm going to swap this one out for the I'll swap this one out. Is that the right hole? Yeah. I'm going to take that one out. God, this was the legs are too small on there. I must have cut legs off it. They're very short. Right, that's in. Let's see if that one triggers okay. Yeah, it's working. There was a delay before it came up actually. That's because these capacitors are balancing out. Yeah, it came up with an 82 ohm on. I need to check my my split rail voltages might be not be very well balanced, so I need to check between here and here. Oh yeah, they're way off. That's 5.7. No, that's probably not far off. What, 5.7 on this side. And 5.69 on that side. Wow, that is perfectly balanced. That is really. I've got a good split rail on there. The main problem I seem to have is with the this capacitor is loose. Is with the op amp. I need to balance that amount. That op amp needs to be balanced more. Let's just check that. Oh, it just cuts off at it. I moved it a tiny bit and it went off straight away. It's very touchy, this op amp. The voltage has to be perfectly balanced on the input. So this no, actually that's probably right, yeah, because you bias the op amp has to be balanced so you get amplification. my waveform, it just shifts quite a long way when I adjust that trimmer part. It doesn't adjust the gain. It adjusts the offset. This trimmer does. Oh, okay, Alan. Yeah, and thanks a lot anyway for everything you're doing as well. And have a really nice Christmas as well. Just saying, because I'm not sure if I might see you again until before Christmas. You never know. But yeah, yeah, we'll have a chat later. My daughter's been staying over with me, by the way, so she's gone out with some friends. She's going to be turning up a bit later. She's staying over for a couple of days, which is really nice. My younger daughter, that is. She's that's Joanna. She's out with friends right now, and so anyway, we'll talk to you later, Alan. Yeah, that'd be great. Yeah. I need 2 more of those little tiny ones. The slightly longer ones. You know, the thing. Yeah. Okay. Take care. Oh, cool. Okay, that's brilliant. Yeah, cool. Okay, have fun. I am gonna make some more coffee because my coffee has gone freezing cold. It's absolutely freezing. I keep forgetting to drink it, you know, that's the problem. Okay, so the output is still not square. I still haven't got a square wave coming out for some reason. I just don't know why. Maybe it's just, maybe the scope is just, maybe it's because the capacitor in the oscilloscope, because there's a capacitor in the oscilloscope, maybe it's that's the problem. I don't know, it shouldn't be. It should read square waves if it's square waves. This should be latching, unless I'm overdriving it. That could be the problem. So what I need to do is the output, I need to put a resistor between the output of the op amp and the input of this. So I'm going to look for a resistor that I can stick across there to see if that helps with the stabilizing it, because there's something not quite right. Let me just, that's not really connected to anything. So what value is this one? That's 3.2k. Actually, I could use that one. I'm clipping onto my power there, so I'm going to use this. I'm just going to use this one to clip on my power. Right, and I'm going to use that one as my. Oh my god, this wire is going to be a bit tricky. Let's see, what can I put this? Well, what I can do is I can move this wire. Are we off? No, we're on. I'll move this wire that's for the input of there over to a spare hole over here. I'll stick it in there. And I'm going to put the resistor between the output of the op amp and the input of the hex inverter, and turn it on again. Okay, it's working. It's just the same as it was though. It's no more squarer than it was, so that's not helping much. Why the hell is this not? Maybe this value, I should be getting feedback from the output. Oh, of course, maybe it's because I'm pulling it down too much with this trimmer. I don't know, it shouldn't be that. Oh, maybe I need to put a resistor between these two stages as well. That shouldn't do though. The output of that hex, that second hex on this side, should be keeping that other one on. Maybe this resistor is too low. Maybe that's what it is. I need to increase the resistor, this resistor a little bit more. I'm going to watch a bit more of that video that Easy Projects produced, because it might have overlooked something. So I'm just going to play the rest of that video.
This one over here, and just forget about that. So now that we started to use 3 of the inverters, we can make another circuit that will not be as stable as this one. So let's take a look at that one. So if we once again take 3 of the inverters, and we just put a
that's now
so
that's an oscillator
in one chain. Then we'll try to set a 1 here, and that'll be a 0 here and a 1 here, and a 0 here, but that's already a 1, so what will happen? Well, you might think that the chip will short out and blow up, but that's actually not what happens.
Because of the delay.
Delay for this one to get through to the other side to be 0. So there's a delay from this, the delay goes here, then the delay through here. So when this one becomes a 0, if the work gets all the way to the end again, it becomes a 1. There will be some.
These packets get worse.
So this will be smaller. So you can make an oscillator out of the odd number of inverters. So you can have 3, 5, 7, 9, or whatever you want. But the more inverters you have, the longer the delay will be, and therefore the slower the output frequency. And you can find all these delays in the data sheet, but in my opinion it's easier just to try it out and see if it works. So let's do that. So here's the circuit, and it's even simpler than the other one. We just have 3 jumper links, one going from the output of the first inverter to the input of the next, and from the output of that one to the input of the next, and then this one goes from the output of the last inverter.
Well, yeah, I don't want to build an oscillator, which is what that is. You know what I need? I need to go and get my logic probe. Test it at low frequency. I'll go and find it. I'm trying to find my logic probe at the moment. Oh, you never guess what I found. You never guessed what I found. Something I made a very, very long time ago. This is on Paxlin board. This is something I made, what, 20, 30 years ago? My God, it's still got components in it. I never stripped the components out. Do you know what it is? Do you want to know what it is? Anyone want to know? The chips aren't in it anymore because I took the chips out. And you guess what this is? It's a huge board. Board. Yeah. Bored. Boring? No. Right, okay. Drop my blooming torch again. Well, I actually wrote on here in pencil. This is a stereo multiplexer using discrete components and 2 ICs. And it works. Well, it worked until I took the chips out, and all my components are completely crushed, and that's why it's got high quality polystyrene capacitors in. Let's see, when did I make this? It's got, I put on my name at the bottom there. It's gone oxidized a bit though now. Let me see if I can get this on camera so you can read it. Let's see if you can actually read that. The light's probably bad again. Let me see if I can get this lined up. Right. Let's see if I can get this lined up for you to read. Get the angle so that the magnifying glass doesn't reflect. Right. It's my old name as well. It's not even my new name. This was all done by hand. I didn't have a computer then. It was designed by me and Richard. And my name's on it. Oh God, I'm drifting off camera again. Just a minute. Richard designed the circuit primarily. Let me just get the preview up thing. Hang on, because I can't see what. Let me get this preview window. Right, let me try again. I was drifting off camera all the time. So we can get this on. Right, where are we? Is this light? I'll turn this light off. It's too bright. Now, you should adjust the brightness levels anyway, and you should be able to read in a sec. Just a minute. We have to get the focus right so you can actually read the dates and everything. I need to get a little, tilt it back a bit so I can get the other light on it. Oh, this is no good. It's just too dark. The copper's gone really dull as well. It's just oxidized. Oh, I took a chip out of there as well. I wonder what it must have been a 555 or something. Oh, there's 2 chips missing. Oh, I must have. Yeah, there was a lot of components on there. There was 4 chips on there. It would work if I'd put the chips back in. Oh, this isn't working too well. This light source is just no good. If I get close to the camera. Ah, right. Oh, we're getting there. Just a minute. Right, there's me and Richard on there somewhere. We both collaborated to design a stereo encoder. It's actually an FM stereo encoder and multiplexer. These days you can buy them on one microchip. You can actually get them on a single chip, but we built it with discrete components and a few chips. It's a highly complicated circuit. You use a 19 kilohertz tone that basically lights up the LED on a radio, and that is that 90 kilohertz tone is doubled to produce 38 kilohertz, which is the carrier waveform where half the stereo information is on, and the channels left and right are split. So there's a mono audio signal which basically forms the full mono signal, and it forms the other half of the left and right channel, and the left and right channels are carried on the 38 kilohertz frequency, and you use a decoder which basically it's like a sideband on a radio. It basically takes these signals and puts them back together again on the receiver side. You know what, I'm going to put this in the scanner and scan it, because I just can't get it on the flipping magnifying glass. Anyway, the date, let me see. Let me read it to you because I can't get it on there. The date is 1990, February 1990. So it's February 1990. We made this. And it's kind of a shame that I dismantled it, you know. There's a regulator on the board there. It's a 78L05, so it was a 5-volt regulator for the flipping server's gone off again, and there was a Zener diode there as well. And there's actually onboard switches for the 19 to switch the 19 kilohertz on and off. Oh, that's it, the switch is there. Little tiny switches. There are rocker switches as well, miniature rocker switches. I don't think you see those anymore. Now they're all them slide ones. These are rocker switches. So, yeah, this is how long I've been building stuff. Oh, I can't get it on the scanner right now. The fan's on there. So, I'll show it. I'll scan it later. I'll scan it later. Am I still live? Well, it looks like I am. need to refresh this window because it's two of the preview windows were just giving circles to me, running circles on me. See. Yeah, I'll scan that board later and show you it so I can see it a bit better, or I can take a photo on my phone or something. Yeah, I was looking for my logic probe and I don't know where I put it. Oh, of course, it was hanging up. It was hanging up at one point, and I think it's actually in this cupboard here somewhere, buried. It's probably under this lot. Oh, I found it. Right. Okay, this will make life so much easier. Right, I've got my logic probe. Right, it's TTL, all on TTL, so I'm going to check for I'm going to check the outputs with my logic probe. So what I'll need to do is turn off the input signal and see if I can flip it and get it to flip on. I could stick LEDs on the output, but why do that when I can use my logic probe? It's so much easier. So I'm going to clip this onto ground. I'll clip. This is the power for the logic probe. Oh, damn it! Come on. I need something to. I need the power positive end to up here. Right, we're connected. Now I need to disconnect the input signal because I want to see if I can flip it. If it's flipping, if this these other two inverters are working properly, then they should technically switch between positive and negative, positive and negative. And the other way to find that out is to disconnect the input signal and then pulse it just briefly and see if it flips either way. So I'm going to disconnect the input signal. Right. I'm going to connect to the output there. It's actually green right now. Let's pulse. No, it's red. So yes, it's working. Pulse it again. It's getting a high frequency, don't forget. You can see that the signal's alternating. Look. Actually, are you able to see that? Because I've got an obstruction on my camera again. Right, yeah, we can see it's pulsing, can't you? So if I disconnect the input signal, it should stay on either red or green. And it seems to be mostly on red, so there's a problem. I'm just going to disconnect that end. It's clearly not working the way it's supposed to be. So let me pulse the input. I should be able to get it to flip onto green. Well, it's on green when I put it on. green right now. So yeah, my seems to be going back onto red, so it's not this. It's clearly not working. No, it's not working the way it's supposed to be. Okay, now I've verified that I've got a problem. It's balanced, not balanced properly. So now I connect the input signal again. Right, so if I connect the output, disconnect the output from that op amp, right, I'll stick it in an empty hole. It's not connected right now, so now the output so what I need to do now is put a coupling capacitor between the output of the op amp and the input of this IC, so that we don't actually have DC going into the circuit, which is probably what's causing the problem. So what I'll do is find, let's see, I need to find the potential between the output of the op amp and the input of this chip. So I need to find out which is higher potential, which end has a higher DC, because I have to find out if I need a polarized capacitor and which way around it needs to be. And I have a suspicion, because the op amps center balanced, it's probably going to be high on the output of the op amp. So I'm going to go to the op amp output chip pin, go to the input of the IC, and what do we have? Actually we have 0 volts, that's good. We do have a 0. Right, so that's okay, that's fine. Right. Now I want to know if I can flip it just by touching the input of the IC, because it's very high sensitivity. So can I flip it by touching that leg? Yes, I can. I can flip it. So I know that the hex inverter is working correctly, because I'm going to flip the latch. I can flip it either on high or low by just touching that leg. Now before we get to the latch, the output before it goes to the latch is, let's see, where are we? Is over here, right? So this side, this might latch as well, because yeah, it does, that's fine. But if I go to the earlier stage over here, it may not latch, but it is latch. Well, it's not actually not very good over here. No, it's not as good over here. The latch is over there. This side is not latched, so it's much less reliable. But the latch on this side is you have to be pretty quick. But the latch is working. I know that. That's the main thing. So it's basically a coupling issue. I need to make sure that the coupling between the op amp and the hex inverter is. I'll take this off now because I could pull all my resistors out because these have got hooks on. So I'm going to use this electrolytic actually over here. It's only a 2.2 microfarad, so it should be fine. And I'm going to connect that between fiddly, that's the input resistor, is that on or not? Oh, it's in, I think. Well, I can see the waveform. I should have turned that off while I put it in actually, but it looks pretty good. I think it's trying very hard to become square wave, but I've got some rounding happening somewhere in the circuit. It's probably the input of the scope. Yeah, I don't get it. I don't get it. This should be square wave coming out. I'm going to put my signal generator onto square and see what happens. Okay, right, that's not it. There's not a problem with the circuit because I'm on square and it's still pointy. Now I'm going to put it on triangle. Right, no difference. The circuit is definitely working. Because it doesn't matter if I stick a square wave on the input, or a triangle wave, or a sine wave, the output is the same waveform, so that's good. Oh wow, and the gain, I can turn the gain right down and it still stays the same amplitude. That's really good. Until it gets to too small a signal. So that's excellent. I seem to have a problem with the frequency though. Oh, it's square. It's just I must be losing that square waveform somewhere. The amplitude is much more consistent. you know, I can turn the gain down on the output signal right down and the amplitude remains the same. That's great. When it collapses at a certain point it just vanishes, which is also excellent. I need to fine tune this op amp really. The on time and off time basically is got to be finely balanced. But basically when I was turning the input right down and it didn't, the amplitude on the output on here didn't drop off at all until it got to a certain point. It just went completely off, which is what you want for a trigger circuit. You want a stable signal for the trigger, and that's pretty much what I'm getting. I'm just not happy with the waveform right now. I'm just trying to get it more square. I've got quite a bit of noise. It's just that these connections in these sockets are very, very poor. You know, move things around and you see jitter. But it'll be a lot better when it's on a proper circuit board, that's for sure. So actually having this capacitor in here, I don't think this is helping much, so I'm going to take that out. And turn it off a minute and put that wire back, turn it back on, actually that capacitor does make a difference. I think it seems to come on faster. I think, I'm not sure. I'll just put it back in again. I'll just move that link over to the... Oh, I've got it on the other side of the resistor. No, the other side. Come on, you bugger, what's the matter with you? I'll move it to this side. Right, turn it off. Turn it on. No, it doesn't make much of a difference, that. So I'm going to take the capacitor out because it's not making much of a difference. I'll just leave it direct to that input of that. The fewer components I can use, the better, really. So the output is, I think it's the filter capacitor. This filter capacitor I put in is actually nulling the higher frequencies that I want, you know, RF it would do. So I'm going to take it out. Right, take them out completely, this filter for now. That waveform looks better actually. It's the filter capacitor that's giving me some problems. What I'm going to try is another technique is to use a filter capacitor in series with a resistor. So if I have another ground wire, take this one out because it's not being used. Come out. I'm going to have a ground wire in series with that capacitor in series with the resistor. This should help to remove some noise, but it'll be a lower stick it in there, I think. Check the stream. Still running. Right, so I need to find another resistor that's something like quite a lower resistance, actually, something like what have I got in here? I want something low now, so I'm going to stick this on ohms. 68.8 ohms. Well, let's try that. Shouldn't do any harm to the output. I'll stick this capacitor between the stages. Current might go up a bit though. Doesn't seem to change it. That's good. It's only supposed to remove some noise. I'm going to check my current again. It was about 20 milliamps before, so I don't want to be consuming too much current, so let's see what it is now. Oh, it's down even more, it's 17 milliamps. $16 milliamps, that's 15 milliamps, it's charging capacitors up, you see. 15 milliamps, that's excellent. It's still going down, 13 milliamps. 12 milliamps. 11. 10. 9. The current is going way down. I'm not complaining about that. Hang on, I've lost it now. Just a minute. Oh, look. You see the current consumption is dropping, which is even better. Oh, the camera's moved, I think. Is that better? You can see it. It's because I've disconnected it a minute, it's gone back up again, it's going back down. Current consumption, that is amazing. It's actually falling. Yeah, this circuit is drawing about 9 milliamps at the moment. I am on DC, I think. Yeah, I'm on DC. $8 milliamps. 7 milliamps. What the hell's going on with this thing? It's consuming so little power. Alright, it's stabilised at about 7 milliamps. That is great. I mean, low power is better, really. It might be also dependent on the frequency I'm putting into it as well. it's dropped to about 6.8 milliamp consumption. Right, I'm happy with that, but I'm going to monitor it for a bit because I want to see if it changes with frequency as well. So what I'm going to do is find another lead to put another clip on here. Oh, damn it, why is it tangled up? I'll turn it up a minute while I find a lead. Right, I've got one. So I'm going to clip this onto my positive lead because I want to keep an eye on current consumption anyway, really. Stick that resistor box over the top of that wire so it doesn't move around. Right, turn it on. Right, it's back at 17 milliamps. Right, I'm going to try some other frequencies. I'm going to have to point the meter the other way because I'm over there when I'm doing that. I want to see what's happening. I'll change my frequency a bit. It's still dropping, it's not showing the frequency higher. Yeah, current's still lower than milliamps. I need a high frequency. Oh, it just disappears at high frequency. It is tapering off. I don't know, what frequency is this tapering off at? Maybe I'm reaching the maximum frequency of that chip. The latch, the hex inverter, maybe that's the problem. Yeah, that could be what it is. The reason why I'm not getting a proper square wave is at 8.8 milliamps at higher frequency. The reason I'm not getting a proper square wave is probably something to do with the 4069. So maybe I should try that other chip because it's pin for pin replacement, I think. So I think I will try the other chip and see if the frequency is different, because there's a definite roll off. And what frequency? I don't know what frequency I'm at either right now. So I need to put this power directly on there a minute again. So what frequency are we? What frequency are we at? So just a minute. I need to put that one on ground. What frequency is this at? 8.8 kilohertz. Well, that's not good. I don't want it rolling off on me at just around 10 kilohertz. Eight kilohertz. I mean, that's not good. So it's the waveform amplitude is dropping rapidly to around 8 kilohertz. So that secondary chip must be the problem, unless the op amp is dropping. No, it can't be that. The op amp can't be the problem because, like I said, this chip, the hex inverter, it always produces maximum positive rail or minimum. So if it's switching, it should still be maximum output. But I'm going to compare the difference anyway. It's still switching. It would give up switching actually if it went to a too high frequency. So that won't be the problem. Sorry, this one won't be the problem. This one could be. I don't know. Anyway, we'll find out. I really need to have both traces with the scope on. Actually, I'm going to hook the other scope beam on. And I'm going to, oh damn it, I've dropped all my bits. I'm going to put the other beam on and I'm going to monitor both the output of the op amp and the hex inverter. I want to monitor both. If I can find another lead. Oh, I'll have to use that one. That will work. Off the other oscilloscope. Take that one off. Turn the beam on. I'll put them both on 1 volt peak to peak. Right. Oh, this flipping lead's too short. At least I only need one wire because it's already grounded, so right. Oops, I want to be on AC as well. Yeah, so if I clip this end, this other end to the other beam on the op amp circuit, then I should be able to see what if the op amp is dropping off or what. I need another jumper. This wire will have to do. It's not connected to anything. So I'm going to jump this across from the output of the op amp, which is actually over here, so I can clip it in there. And I'm going to jump that across to that capacitor there and clip onto that. Now I've got two waveforms and the op amp is a lot higher, so I'm not sure actually. Looking on AC. Yeah, the op amp is higher. I'll just go to the higher setting. Right, op amp is there. It's definitely not very square. Okay, now I'll be able to see which is falling off. I'll bring the camera over, it's a bit jittery. Now, oh damn it, I need to get this locked again. Okay, this waveform is. Are you looking at that? Yeah, you can see that. Right, this waveform, the one I'm moving up and down with my hand, that is the op amp. Right. The other waveform, this one, is the hex inverter. Right. Let me just zero that out again. Right. So when I turn the frequency up, oh, that's down. I turn the frequency up, we see that the hex inverter is dropping, which means that the frequency of the hex inverter is very poor. Right? The op amp is still good because I know that can go up to 15 megahertz. So the hex inverter is dropping rapidly as I go up in frequency, which means that that hex inverter is no good for what I want. The hex inverter can't keep up basically with the op amp. It's dropping off, look. The op amp is great, it's as steady as a rock. As amplitude, the amplitude of the op amp is rock solid. I knew it would be because it's up to 15 megahertz. But this hex inverter can't cope. So I'm going to try the other one. This is why I need this is why I'm building this circuit, is to get a stable trigger pulse, and you can see why. I'm not using this as a trigger pulse right now, I'm just monitoring it on the scope. Okay, right. Oh, I can't tell when I'm not on the when I'm not looking at it. Sorry about this. My hand's drifting about. Right. So basically, when I turn the frequency up, like that, the hex inverter falls off to a tiny signal, drops right off. So that the other big one is the op amp, right? The one that's at the high amplitude is the op amp, and the hex inverter is collapsing to nothing. So I'm going to try the other one. That's why I'm not getting a square wave at higher frequencies. Let's go back down to a lower frequency. You see, it's square at lower frequencies. It's working a lot better there, look. Right? That's op amp. And hex inverter off. Right, so anyway, I'll put the other chip in there. Okay, right. And we're currently at 19 kilohertz. It works pretty well. But not good enough for what I want. Right, I found the other IC. guess the reason they suggested you the chip was because it's got a better frequency response. And that's it. That is the MM74HC04N. The one they suggested. It should be pin for pin replacement. I need to print out the pinouts because I want to make sure then my lighter up. Ooh. I need a coffee, I really do. Right, so can I get this IC out without moving all these resistors? Well, that resistor is going to have to be moved because actually I can still do it. I just don't want to move all my components around because whenever you do that you start pulling things out and you forget where they go. That's when errors and mistakes happen. So I'm going to get this other chip out. Oh, I haven't printed. HCF, where is it?